The creation of life, from cosmic origins to human consciousness. Introduction. The question of how life began is one of the oldest and most profound mysteries humanity has ever faced. Across thousands of years, civilizations have developed myths, religious teachings, philosophical systems, and scientific theories to explain the origins of life and existence itself. Ancient cultures looked to the heavens and imagined gods shaping the earth from chaos. Philosophers searched for reason and order in nature. Scientists eventually turned to observation, experimentation, and evidence to uncover the processes that may have led to life emerging from a lifeless universe. The creation of life is not simply a scientific topic. It is also a spiritual, philosophical, and emotional journey that touches every human being. Every person wonders at some point why life exists at all. We ask where we came from, what purpose we serve, and whether there is meaning behind the complexity of living things. The search for answers has inspired religion, poetry, art, medicine, astronomy, biology, and nearly every field of human thought. Today, the study of life's origins combines many disciplines. Astronomy examines the birth of stars and planets. Chemistry studies the formation of molecules. Biology explores the development of cells and organisms. Anthropology investigates the rise of humanity and civilization. Meanwhile, philosophy and spirituality continue to reflect upon the deeper significance of life itself. The creation of life can be understood on many levels. Scientifically, it involves the transformation of matter into self-replicating organisms. Spiritually, it may represent the unfolding of divine intention or universal consciousness. Philosophically, it raises questions about reality, identity, morality, and purpose. Culturally, it has shaped civilizations and human values. This essay explores the creation of life from multiple perspectives. It begins with the origins of the universe and the conditions that made life possible. It then examines scientific theories regarding the emergence of life on Earth, the evolution of organisms, and the development of human consciousness. It also explores religious and spiritual interpretations from different traditions around the world. Finally, it reflects on what the creation of life means for humanity today and what the future may hold. The story of life is the story of everything: stars, oceans, cells, animals, people, dreams, suffering, hope, love, and consciousness itself. To understand life's creation is to understand humanity's place within the universe. Chapter 1: The Birth of the Universe. Before life could exist, the universe itself had to come into being. According to modern cosmology, the universe began approximately 13.8 billion years ago in an event known as the Big Bang. This theory suggests that all matter, energy, space, and time were once compressed into an unimaginably small and dense point. Suddenly, the universe expanded rapidly, creating the foundations for galaxies, stars, and planets. The earliest moments of the universe were incredibly violent and hot. Elementary particles formed within fractions of a second. As the universe expanded and cooled, these particles combined into atoms, mostly hydrogen and helium. Gravity gradually pulled matter together, forming giant clouds of gas that eventually became stars. Stars played a crucial role in the creation of life. Inside stars, nuclear fusion produced heavier elements such as carbon, oxygen, nitrogen, and iron. These elements are essential for living organisms. When massive stars exploded as supernovae, they scattered these elements across space. New stars and planetary systems later formed from this enriched material. In this sense, life is literally made from stardust. Every carbon atom in the human body was forged within ancient stars billions of years ago. The oxygen we breathe, the calcium in our bones, and the iron in our blood all originated in cosmic furnaces. The formation of galaxies created environments where planets could emerge. About 4.6 billion years ago, our solar system formed from a cloud of gas and dust. At its center, the sun ignited. Around it, planets gradually took shape through collisions and accumulation. Earth formed approximately 4.5 billion years ago. At first, it was a hostile world filled with volcanic eruptions, molten rock, toxic gases, and constant meteor impacts. Yet over time, Earth cooled enough for oceans to form. These oceans would become the cradle of life. Scientists believe several conditions made Earth uniquely suitable for life. It lies within the sun's habitable zone, where temperatures allow liquid water to exist. Water is essential because it acts as a solvent for chemical reactions. Earth also possesses a magnetic field that protects the planet from harmful solar radiation. Its atmosphere helps regulate temperature and provides gases necessary for living organisms. The creation of the universe reveals an astonishing chain of events leading toward life. Tiny fluctuations in energy eventually produced galaxies, stars, planets, oceans, and living beings capable of reflecting on their own origins. For many people, the universe's complexity and fine balance suggest deeper meaning or intelligent design. Others view the emergence of life as the natural consequence of physical laws operating over immense spans of time. Regardless of perspective, the existence of life within such a vast universe remains extraordinary. Chapter 2: The Early Earth and the Conditions for Life. The early Earth was vastly different from the world we know today. Around 4 billion years ago, the planet's surface was unstable and chaotic. Volcanoes erupted constantly, releasing gases into the atmosphere. Meteorites bombarded the young planet. The skies were likely filled with ash and storms. There were no plants, animals, or oxygen-rich air. Despite these harsh conditions, Earth possessed something incredibly important: liquid water. Scientists believe water arrived through volcanic activity and possibly from icy comets striking the planet. Over millions of years, oceans formed across Earth's surface. The oceans created environments where chemical reactions could occur continuously. Many researchers believe life began within these ancient waters. The earliest atmosphere likely contained methane, ammonia, hydrogen, carbon dioxide, and water vapor. Lightning, ultraviolet radiation, and geothermal heat provided energy capable of driving complex chemistry. One famous scientific experiment demonstrating this possibility was conducted in 1953 by Stanley Miller and Harold Urey. They recreated conditions believed to resemble Earth's early atmosphere and introduced electrical sparks to simulate lightning. After several days, amino acids, the building blocks of proteins, formed naturally. This experiment suggested that organic molecules necessary for life could emerge from non-living matter under the right conditions. Scientists have proposed several theories regarding where life first originated. One possibility is that life began in shallow pools warmed by sunlight and volcanic heat. Another theory suggests hydrothermal vents deep within the ocean provided ideal conditions. These vents release mineral-rich water heated by Earth's interior. Hydrothermal vents remain especially intriguing because modern ecosystems thrive around them, even without sunlight. Certain bacteria use chemicals from the vents to produce energy, demonstrating that life can survive in extreme environments. The transition from chemistry to biology remains one of science's greatest mysteries. At some point, molecules became capable of self-replication. RNA is often considered a likely candidate because it can both store genetic information and catalyze chemical reactions. Once self-replicating molecules emerged, evolution could begin. Natural selection favored molecules that reproduced more effectively. Over time, increasingly complex systems developed. Eventually, primitive cells formed. These early cells likely possessed membranes separating internal chemistry from the outside environment. This boundary allowed cells to regulate their internal conditions and become more stable. The appearance of the first living cells marked a turning point in Earth's history. Life had begun. Chapter 3: The First Life Forms. The earliest life forms on Earth were microscopic organisms similar to modern bacteria. Fossil evidence suggests life existed at least 3.5 billion years ago, though some evidence indicates it may have emerged even earlier. These first organisms were simple, single-celled creatures lacking nuclei. Yet despite their simplicity, they represented a remarkable achievement of natural processes. They could grow, reproduce, adapt, and interact with their environment. Early life likely depended on chemical energy rather than sunlight. Some microorganisms consumed compounds from volcanic vents or the surrounding environment. Eventually, however, certain organisms evolved photosynthesis. Photosynthesis transformed Earth forever. Through this process, organisms used sunlight to convert carbon dioxide and water into energy while releasing oxygen as a byproduct. Cyanobacteria were among the first photosynthetic organisms. Over millions of years, they produced enormous amounts of oxygen, gradually altering Earth's atmosphere. This event, known as the Great Oxygenation Event, occurred approximately 2.4 billion years ago. At first, oxygen was toxic to many early organisms. Yet eventually, some life forms evolved ways to use oxygen efficiently. Aerobic respiration allowed cells to produce much more energy than previous methods. This increase in available energy enabled greater complexity. Cells evolved specialized structures called organelles. One theory, known as endosymbiosis, proposes that mitochondria and chloroplasts were once independent bacteria that formed cooperative relationships within larger cells. These larger, more complex cells are known as eukaryotes. They eventually gave rise to plants, fungi, animals, and humans. For billions of years, life remained microscopic. Yet even during this period, evolution was continuously experimenting with new forms and strategies. Organisms adapted to changing environments, competed for resources, and diversified. DNA became the universal language of life. Through genetic information stored in DNA, organisms could pass traits to future generations. Mutations introduced variation, and natural selection favored advantageous traits. The creation of life was not a single moment, but an ongoing process of transformation and adaptation. Tiny organisms slowly reshaped the planet's atmosphere, oceans, and geology. They laid the foundation for all future life. Modern humans often overlook the importance of microbes, yet they remain essential to life today. Microorganisms recycle nutrients, produce oxygen, aid digestion, and influence ecosystems across the planet. The first life forms demonstrated one of the universe's most extraordinary abilities, matter organizing itself into living systems capable of growth and evolution. Chapter 4: Evolution and the Rise of Complexity. Evolution is the process through which life changes over time. Charles Darwin's theory of natural selection revolutionized humanity's understanding of life by explaining how complex organisms could arise gradually from simpler ancestors. Natural selection operates through variation, inheritance, and survival. Organisms within a species differ slightly from one another. Some variations improve survival or reproduction. These beneficial traits become more common over generations. Evolution does not follow a predetermined plan. Instead, it is shaped by environmental pressures and chance events. Yet over immense periods of time, evolution has produced astonishing diversity and complexity. Approximately 600 million years ago, multicellular organisms became widespread. Cells began cooperating within larger bodies, allowing specialization. Some cells handled movement, others digestion, protection, or reproduction. This cooperation enabled the rise of increasingly advanced organisms. Around 541 million years ago, the Cambrian explosion occurred. During this period, many major animal groups appeared relatively rapidly in geological terms. Oceans filled with diverse creatures possessing shells, eyes, and nervous systems. Life gradually expanded onto land. Plants evolved structures to survive outside water. Insects followed, then amphibians, reptiles, birds, and mammals. Mass extinctions repeatedly reshaped Earth's ecosystems. The most famous extinction occurred 66 million years ago, when an asteroid impact contributed to the disappearance of dinosaurs. These catastrophic events often opened opportunities for surviving species. Mammals, once small and relatively insignificant, diversified after the dinosaurs vanished. Evolution demonstrates that life is resilient and adaptable. Organisms continuously respond to environmental changes. Over billions of years, simple cells evolved into forests, whales, insects, birds, and human beings capable of abstract thought. The evolutionary process also reveals humanity's connection to all living things. Humans share genetic similarities with countless species. Every organism on Earth belongs to one vast family tree of life. This understanding has profound philosophical implications. Humanity is not separate from nature, but deeply intertwined with it. The same processes shaping bacteria, trees, and animals also shaped us. Evolution remains active today. Viruses mutate, species adapt to climate change, and ecosystems shift continuously. Life is dynamic rather than fixed. The rise of complexity through evolution demonstrates the incredible creative potential of natural processes operating across deep time. Chapter 5: The Emergence of Human Beings. Humanity's origins are part of the broader story of evolution. Modern humans, known scientifically as Homo sapiens, evolved in Africa approximately 300,000 years ago. Before modern humans emerged, many other hominin species existed. These included Australopithecus, Homo habilis, Homo erectus, and Neanderthals. Each species possessed unique adaptations and behaviors. Early human ancestors gradually developed larger brains, upright walking, tool use, and social cooperation. These traits improved survival and allowed greater flexibility in changing environments. Fire was one of humanity's greatest discoveries. It provided warmth, protection, and the ability to cook food. Cooking increased nutritional value and may have contributed to brain development. Language transformed human existence. Through language, people could share knowledge, preserve memories, coordinate activities, and create culture. Humans also developed symbolic thinking. Cave paintings, burial rituals, music, and art reveal a growing awareness of identity, spirituality, and meaning. Unlike other animals, humans could imagine the future, reflect on the past, and contemplate abstract ideas. Agriculture emerged around 12,000 years ago. Instead of living solely as hunter-gatherers, humans began cultivating crops and domesticating animals. Permanent settlements formed, eventually leading to cities and civilizations. Civilization brought tremendous advances in science, writing, philosophy, engineering, and governance. Yet it also introduced warfare, inequality, and environmental challenges. Human consciousness remains one of life's greatest mysteries. The human brain contains billions of neurons forming incredibly complex networks. From this biological structure emerges awareness, thought, emotion, creativity, and self-reflection. Some scientists view consciousness as an emergent property of neural activity. Others believe consciousness may involve deeper aspects of reality not yet fully understood. Human beings occupy a unique position in Earth's history. We are products of evolution, yet we also possess the ability to alter ecosystems, explore space, and study our own origins. The emergence of humanity represents both continuity and transformation. We remain biological organisms shaped by natural processes, yet our intelligence allows us to transcend many limitations faced by earlier life forms. Humans now hold enormous responsibility. Our actions influence the future of countless species and ecosystems. Understanding the creation of life should inspire humility, gratitude, and care for the living world. Chapter 6: Religious Interpretations of Creation. Long before modern science emerged, human societies developed spiritual explanations for the origin of life. These creation stories often expressed cultural values, moral lessons, and humanity's relationship with the divine. In Judaism, Christianity, and Islam, God is described as the creator of the universe and all living things. The book of Genesis portrays creation occurring in stages, culminating in the creation of humanity. According to Genesis, God created light, sky, land, oceans, plants, stars, animals, and finally human beings. Humans were made in God's image and entrusted with stewardship over creation. Christian interpretations vary widely. Some believers understand Genesis literally, while others view it symbolically or metaphorically. Many religious thinkers accept scientific evolution while believing God guided the process. Islam teaches that Allah created life with wisdom and purpose. The Quran frequently encourages reflection upon nature as evidence of divine power. In Hinduism, creation is often viewed as cyclical rather than linear. The universe undergoes endless cycles of creation, preservation, and destruction. Brahma is traditionally associated with creation, Vishnu with preservation, and Shiva with transformation. Buddhism focuses less on a creator deity and more on the interconnectedness of existence. Life arises through dependent origination, where all phenomena emerge through causes and conditions. Indigenous traditions around the world possess rich creation stories deeply connected to nature. Many describe humanity emerging from the earth, animals, or spiritual ancestors. Creation myths often share common themes: order emerging from chaos, the sacredness of life, humanity's connection to nature, moral responsibility, the search for meaning. Religious perspectives continue to shape how billions of people understand life's origins. For many individuals, science explains how life developed, while spirituality addresses why existence matters. The relationship between science and religion has often been portrayed as conflict, but many scholars argue they address different dimensions of reality. Science investigates mechanisms and evidence, while religion explores meaning, purpose, morality, and spiritual experience. The enduring power of creation stories reveals humanity's deep desire to understand existence beyond material facts alone. Chapter 7: Philosophy and the Meaning of Life. The creation of life naturally leads to philosophical questions about meaning and purpose. Why does anything exist at all? Is life accidental or intentional? What gives human existence value? Philosophers across history have wrestled with these questions. Ancient Greek thinkers such as Plato and Aristotle explored concepts of order, reason, and purpose in nature. Aristotle believed living things possessed intrinsic purposes guiding their development. During the Enlightenment, philosophers increasingly emphasized reason and scientific inquiry. Thinkers such as Descartes, Kant, and Spinoza examined consciousness, morality, and humanity's relationship to the universe. Existentialist philosophers later confronted the apparent indifference of the universe. Jean-Paul Sartre argued that humans must create meaning through choices and actions. Albert Camus described the tension between humanity's search for meaning and the universe's silence. Yet he believed people could still live with dignity and purpose. Some philosophers argue life's meaning arises from relationships, creativity, knowledge, love, or moral responsibility. Others believe meaning is subjective rather than universal. The creation of life also raises ethical questions. What responsibilities do humans have toward other living beings? How should society treat the environment? What obligations accompany technological power? Modern biotechnology allows humans to manipulate life itself through genetic engineering, cloning, and artificial intelligence. These developments create profound ethical challenges. Philosophy encourages critical reflection upon humanity's role in the broader web of life. Regardless of worldview, most people seek connection, purpose, and understanding. The mystery of existence inspires wonder and humility. The search for meaning may itself be one of humanity's defining characteristics. Chapter 8: Consciousness and the Human Mind. Among all known forms of life, human consciousness remains uniquely complex. Consciousness involves awareness of oneself and the surrounding world. Humans experience thoughts, memories, emotions, imagination, and self-reflection. The origins of consciousness remain deeply mysterious. Neuroscience has identified many brain structures associated with perception, emotion, and cognition. Electrical and chemical activity within neural networks gives rise to mental experiences. Yet scientists still struggle to explain how subjective experience emerges from physical matter. This challenge is often called the hard problem of consciousness. Why does brain activity produce awareness rather than functioning mechanically like a computer? Some theories suggest consciousness emerges from complex information processing. Others propose quantum effects may play a role. Certain philosophers and spiritual traditions believe consciousness is fundamental to reality itself, rather than merely a product of matter. Human consciousness enables remarkable abilities: abstract reasoning, moral judgment, artistic creativity, scientific discovery, spiritual contemplation, self-awareness. Through consciousness, the universe becomes capable of observing itself. Humans can reflect upon their own mortality, question existence, and imagine realities beyond immediate experience. Consciousness also creates suffering. Humans experience anxiety, grief, loneliness, and fear. Yet consciousness likewise enables love, empathy, beauty, joy, and meaning. The development of consciousness transformed life on Earth. Human intelligence led to language, civilization, technology, and culture. At the same time, humanity's power has created global challenges, including war, pollution, climate change, and extinction. The future of consciousness may involve further evolution. Artificial intelligence, brain-computer interfaces, and genetic engineering could dramatically alter human experience. Some futurists envision humans eventually expanding consciousness beyond biological limitations. Whether viewed scientifically or spiritually, consciousness represents one of life's greatest wonders. Chapter 9: The Diversity of Life. Earth contains an extraordinary diversity of living organisms. Scientists estimate millions of species inhabit the planet, though many remain undiscovered. Life exists in nearly every environment imaginable: deep oceans, frozen polar regions, deserts, rainforests, underground caves, volcanic vents. This diversity reflects billions of years of evolution and adaptation. Plants convert sunlight into energy and produce oxygen. Animals display countless survival strategies, including camouflage, migration, cooperation, and intelligence. Fungi recycle nutrients and form essential partnerships with plants. Microorganisms regulate ecosystems and biochemical cycles. Each species occupies a unique ecological role. Ecosystems depend upon complex interactions among organisms and environments. Predators control populations. Pollinators enable plant reproduction. Decomposers recycle matter. The interconnectedness of life means disturbances in one area can affect entire ecosystems. Human activity increasingly threatens biodiversity. Deforestation, pollution, climate change, overfishing, and habitat destruction have accelerated extinction rates. Scientists warn Earth may be entering a sixth mass extinction. Protecting biodiversity is essential not only for ethical reasons, but also for human survival. Healthy ecosystems provide food, medicine, clean water, and climate stability. Many medical discoveries originate from studying plants and microorganisms. The diversity of life also enriches human culture and imagination. Animals, landscapes, and natural systems inspire art, spirituality, literature, and scientific curiosity. Every species represents a unique expression of life's creative potential. Understanding life's diversity fosters respect for the natural world. Humans are not masters separate from nature, but participants within a vast living network. Chapter 10: Life Beyond Earth. One of the greatest scientific questions today is whether life exists elsewhere in the universe. Given the immense size of the cosmos, many scientists consider it likely that life has emerged on other planets. Astronomers have discovered thousands of exoplanets orbiting distant stars. Some exist within habitable zones where liquid water may be possible. Mars remains a major focus of exploration because evidence suggests it once possessed rivers and oceans. Moons such as Europa and Enceladus contain subsurface oceans that may harbor microbial life. The search for extraterrestrial life involves multiple approaches: studying planetary atmospheres, searching for microbial fossils, detecting radio signals, exploring extreme environments on Earth. Astrobiology combines astronomy, chemistry, geology, and biology to investigate life's potential beyond Earth. If life exists elsewhere, it may differ dramatically from terrestrial organisms. Some scientists speculate about silicon-based life or organisms thriving in environments hostile to Earth life. The discovery of extraterrestrial life would profoundly impact humanity's understanding of existence. Religious, philosophical, and scientific perspectives would all face new questions. Are intelligent civilizations common or rare? Could humanity eventually communicate with other forms of intelligence? The search for life beyond Earth reflects humanity's deep curiosity and desire for connection. Even if humanity never encounters alien life, exploring the universe expands our understanding of our own origins. Space exploration also highlights Earth's fragility. From space, national borders disappear. Earth appears as a small, delicate world surrounded by darkness. This perspective can inspire greater unity and responsibility among humanity. Chapter 11: Technology and the Future of Life. Human beings have entered an era where technology increasingly shapes the future of life itself. Advances in genetics, medicine, robotics, and artificial intelligence are transforming society. Scientists can now edit genes using tools such as CRISPR. Gene editing offers potential cures for diseases, but also raises ethical concerns regarding designer babies, inequality, and unintended consequences. Artificial intelligence may eventually rival or surpass human cognitive abilities in certain areas. Some researchers believe AI could revolutionize medicine, science, and education. Others warn about risks including loss of control, unemployment, surveillance, and ethical misuse. Biotechnology may extend human lifespan significantly. Researchers study aging processes, regenerative medicine, and cellular repair. Some futurists envision radical life extension or even digital consciousness. Humanity also faces global environmental challenges. Climate change threatens ecosystems, food systems, and coastal populations. Pollution harms oceans and wildlife. Deforestation reduces biodiversity and accelerates carbon emissions. The future of life on Earth depends heavily on human choices. Technology can either damage or protect the planet. Renewable energy, conservation, sustainable agriculture, and international cooperation offer pathways toward balance. Human civilization stands at a crossroads. Never before has one species possessed such power over the biosphere. Understanding the long history of life should encourage wisdom and responsibility. Humanity's greatest challenge may not be technological capability, but moral maturity. The future of life will depend upon whether humans learn to cooperate, respect ecosystems, and use knowledge ethically. Chapter 12, Spiritual Reflections on Life. Beyond scientific explanations, many people experience life as sacred. Moments of love, beauty, birth, music, prayer, and wonder often inspire spiritual reflection. The existence of consciousness itself can feel miraculous. Throughout history, humans have sought connection with something greater than themselves. Spiritual traditions teach compassion, gratitude, humility, and reverence for life. Many religions describe life as a gift rather than an accident. Others emphasize unity between humanity and nature. Meditation, prayer, and contemplation allow individuals to explore inner awareness and meaning. Even people without formal religious beliefs often experience awe when observing the stars, oceans, forests, or the complexity of living organisms. Spirituality frequently emerges from the recognition that existence is mysterious and profound. The creation of life inspires both intellectual curiosity and emotional wonder. Science reveals the mechanisms behind natural processes, but many people feel those discoveries deepen rather than diminish appreciation for existence. A cell, a galaxy, or a newborn child can evoke profound amazement. The universe has produced beings capable of compassion, imagination, and self-awareness. Perhaps the deepest spiritual lesson of life's creation is interconnectedness. Every organism depends upon countless others. Humans depend on plants for oxygen, microorganisms for digestion, ecosystems for survival, and social relationships for emotional well-being. Recognizing interconnectedness can encourage empathy and responsibility. Hatred, greed, and violence ultimately harm the shared web of life. Love, cooperation, and wisdom strengthen it. Whether one views life through science, religion, or philosophy, existence remains extraordinary. The mystery of life continues to inspire humanity toward exploration, creativity, and hope. Chapter 13, The Fragility and Resilience of Life. Life is both incredibly fragile and remarkably resilient. A single disease, asteroid impact, volcanic eruption, or climate shift can devastate entire species. Throughout Earth's history, life has endured repeated catastrophes, including mass extinctions that eliminated the majority of existing organisms. Yet life continually recovers, adapts, and evolves. After each extinction event, surviving organisms diversify and fill ecological niches left vacant by vanished species. Forests regrow after fires, coral reefs rebuild over time, animals adapt to new climates and conditions. This resilience reflects one of life's defining characteristics: adaptability. Microorganisms survive in boiling hot springs, frozen glaciers, radioactive environments, and deep underground. Seeds remain dormant for years before sprouting under favorable conditions. Human beings also demonstrate resilience. Societies endure wars, disasters, pandemics, and hardships while continuing to create art, knowledge, and culture. At the same time, life's fragility reminds humanity of the importance of stewardship. Modern civilization has created unprecedented risks: nuclear weapons, ecological collapse, climate disruption, artificial pandemics, uncontrolled technologies. The future of life depends upon collective responsibility. Understanding life's vulnerability can inspire greater appreciation for each moment of existence. Every living organism represents billions of years of evolutionary history. Every species is unique and irreplaceable. Human beings often become distracted by material concerns and forget the miracle of simply being alive. To breathe, think, love, dream, and experience consciousness at all is extraordinary. The story of life teaches both humility and hope. Despite immense challenges, life persists. Chapter 14, Art, Culture, and Humanity's Response to Life. The creation of life has inspired countless forms of artistic and cultural expression. From ancient cave paintings to modern films, humanity has continuously sought to represent existence through creativity. Art allows people to express emotions and questions that may be difficult to communicate scientifically. Music, literature, painting, sculpt, poetry all explore themes of birth, death, love, suffering, and meaning. Religious architecture such as cathedrals, temples, and mosques reflects humanity's desire to honor the sacredness of existence. Stories and myths preserve cultural understandings of creation and morality. Science itself can inspire artistic wonder. Images from space telescopes reveal galaxies of breathtaking beauty. Microscopes expose intricate cellular structures invisible to the naked eye. Human creativity may be one of evolution's most remarkable outcomes. Through imagination, humans transform raw experience into symbols, narratives, and beauty. Culture also shapes humanity's understanding of life. Different societies define concepts such as family, morality, spirituality, and identity in diverse ways. Yet certain themes appear nearly universal: love, mortality, hope, community, curiosity, the search for meaning. These shared experiences connect humanity across cultures and history. The arts remind people that life is not merely biological survival. Life also involves emotion, beauty, imagination, and connection. A scientific explanation of life's origins does not eliminate the emotional depth of existence. Instead, understanding evolution and cosmic history can deepen appreciation for the extraordinary journey leading to human consciousness and culture. Chapter 15: Ethics and Responsibility. The creation of life carries ethical implications. If life is rare and precious, humanity bears responsibility for protecting it. Modern ethical discussions increasingly emphasize environmental stewardship, animal welfare, and sustainability. Humans possess intelligence and technological power unlike any other species. With that power comes moral responsibility. Climate change demonstrates how human activity can alter planetary systems. Burning fossil fuels, deforestation, and industrial pollution affect ecosystems worldwide. Future generations will inherit the consequences of present decisions. Ethics also applies to scientific advancement. Genetic engineering, cloning, and artificial intelligence offer tremendous possibilities, but also serious risks. Questions arise regarding the limits of human intervention in nature, the rights of future beings, equality and access to technology. The definition of personhood. Medical ethics confront issues involving life and death, including organ transplantation, end-of-life care, reproductive technologies, and genetic modification. Different cultures and religions approach these questions differently. Nevertheless, many ethical systems emphasize compassion, dignity, and respect for living beings. The recognition of shared humanity can encourage cooperation across divisions. Throughout history, violence and prejudice have often arisen when people viewed others as less valuable. Understanding humanity's common evolutionary origins can promote empathy and unity. Every person shares fundamental biological and emotional experiences. Ethics ultimately concerns how humans choose to live together within the broader web of life. Knowledge alone is insufficient without wisdom. The future of civilization depends upon balancing technological capability with moral understanding. Chapter 16: Death, Renewal, and the Cycle of Life. Life and death are inseparable. Every organism eventually dies, yet death also enables renewal. In ecosystems, decomposers break down dead matter and recycle nutrients into soil and water. New plants grow from decayed material. Predators regulate populations and maintain ecological balance. Without death, evolution and renewal would stagnate. Human beings often fear death because consciousness creates awareness of mortality. Religions and philosophies have developed various interpretations regarding what happens after death. Some traditions teach reincarnation, while others describe heaven, spiritual transformation, or union with the divine. Scientific perspectives view death as the end of biological function and individual consciousness. Yet even scientifically, no life truly exists in isolation. Human bodies return elements to the environment. Genes continue through descendants. Ideas, memories, art, and relationships influence future generations. The awareness of mortality can deepen appreciation for life. Knowing existence is temporary often motivates people to seek meaning, love, and purpose. Nature demonstrates continuous cycles: day and night, seasons, birth and decay, extinction and evolution. Life constantly transforms. The atoms composing living beings existed long before birth and will continue after death. This perspective can inspire both humility and wonder. Human beings are temporary expressions of a much larger cosmic process. Yet within that temporary existence lies immense beauty and significance. Chapter 17: Humanity's Future in the Universe. Humanity's story is still unfolding. Compared to the age of the universe, modern civilization is incredibly young. The future may involve extraordinary developments: interplanetary colonization, advanced artificial intelligence, genetic enhancement, new forms of consciousness, contact with extraterrestrial life. Space exploration may eventually allow humans to settle beyond Earth. Mars represents a potential first step toward becoming a multiplanetary species. Long-term survival may require expanding into space because Earth will not remain habitable forever. In billions of years, the sun will expand and eventually render Earth uninhabitable. Yet humanity's immediate future depends less on distant cosmic threats and more on present choices. War, environmental collapse, inequality, and misuse of technology could threaten civilization. Alternatively, cooperation and wisdom could create a future of greater knowledge, sustainability, and peace. Education, scientific understanding, and global collaboration will play crucial roles. The story of life demonstrates that complexity and intelligence can emerge from simple beginnings. Humanity now possesses the ability to shape its own evolutionary path. Whether this leads toward flourishing or destruction remains uncertain. The future of life may ultimately depend upon humanity's capacity for compassion, responsibility, and wisdom. Conclusion: the creation of life is among the greatest mysteries and wonders in existence. From the birth of the universe to the emergence of human consciousness, the story of life spans billions of years of cosmic and biological evolution. Stars forged the elements necessary for living organisms. Earth formed under unique conditions, allowing oceans and chemistry to flourish. Simple molecules gradually organized into self-replicating systems. Evolution transformed microscopic cells into the extraordinary diversity of life seen today. Human beings emerged through this long evolutionary journey, developing intelligence, language, culture, spirituality, and self-awareness. Scientific inquiry continues to uncover remarkable details regarding life's origins and development, yet many mysteries remain unresolved. How exactly did consciousness arise? Does life exist elsewhere in the universe? Is existence ultimately accidental or purposeful? Religious and philosophical traditions provide additional perspectives emphasizing meaning, morality, and spiritual significance. For many people, the study of life deepens rather than diminishes awe. Every living organism represents an unbroken chain reaching back billions of years. Every human being carries within them the atoms of ancient stars and the genetic legacy of countless ancestors. Life is fragile, temporary, and precious. Humanity now faces immense responsibilities. Technological power has given humans unprecedented influence over Earth's ecosystems and future evolution. The choices made today will shape the destiny of future generations and countless species. Understanding the creation of life should inspire humility. Humans are not separate from nature, but deeply interconnected with all living things. The same cosmic processes that formed galaxies also formed human bodies and minds. The same evolutionary history connects humanity to every plant, animal, and microorganism on Earth. Despite suffering and uncertainty, life possesses extraordinary beauty. Love, creativity, compassion, curiosity, and consciousness give human existence profound meaning. The story of life is ultimately a story of transformation. From stardust emerged oceans. From oceans emerged cells. From cells emerged forests, animals, and human beings capable of asking questions about existence itself. The universe became aware of itself through living minds. Whether viewed scientifically, spiritually, or philosophically, the creation of life remains one of the most astonishing realities imaginable. It reminds humanity that existence is both mysterious and meaningful. The journey of life continues, and humanity remains part of an unfolding cosmic story far greater than itself. In the end, perhaps the greatest lesson of life's creation is this: despite the immensity of the universe, every living being matters. Every moment of awareness is extraordinary. Every act of kindness contributes to the ongoing story of life. The creation of life is not merely an event in the distant past. It is happening continuously through growth, evolution, creativity, love, and consciousness. Life endures, and through humanity's curiosity and wonder, the universe continues to explore itself. I've created a long-form essay on the creation of life covering cosmic origins, evolution, spirituality, philosophy, consciousness, humanity, and the future of life.